Welcome to the next installment of this Unreal Engine 5 tutorial series where we create a smart enemy AI system inspired by the Xenomorph AI from Alien Isolation. In this week's lesson, because we'll be covering three very distinct topics, I've decided to split them up into three separate videos and release them all together. In part 6, we'll be doing some code cleanup, making our code more efficient, and making some minor performance improvements. In part 7, we'll be implementing prediction sense into our enemy AI. And in part 8, we'll be expanding upon our vision system by implementing multiple vision cones into our alien character in the same style as Alien Isolation. All three episodes are available to watch now, but just ensure that you follow each lesson in order, as each lesson builds upon changes from the last. As always, if you like the content, please like the video and consider subscribing to the channel. And with that out of the way, let's begin with part 6. So in this part, what we're going to do is we're going to take a moment just to review some of the code we've already done and to clean up some of it so it's a bit more efficient, as well as adding some minor performance improvements to our state tree. First of all, what I'm going to do is I'm going to go to the top content folder and then third person blueprints, and then I'm going to move the third person character up into our characters folder here where the alien sits. So we'll just drag that and click move here. So now if we go to our characters folder, we have the alien character and the third person character in our custom blueprints folder. Now, the first thing that we're going to work on today is the evaluator we created in our previous episode. So if we go into our tube content folder, blueprints, AI, alien, and then the ST evaluators, and then let's open up our evaluate perception evaluator. We go back to the event graph. And the first thing that we're going to do is we're going to change the way that these events are implemented. Rather than having them being implemented in this particular evaluator, we're going to set up the bindings in the parent evaluator. So what we'll do is we'll just highlight these three nodes here, drag this up a little bit, and then I'm going to right-click this collapsed node and then click expand. And that will re-expand the nodes that we collapsed. And I'm going to highlight all of these, and I'm also going to shift and then highlight the events as well. And I'm going to press Control X to cut. And then if we go all the way up here into the top right-hand corner, you'll see that the parent class is listed here, the Alien Evaluator base. If we click this little edit option here, it will open up the parent class like so. And then I'm just going to click Control V to paste. So now we've got our bindings and event dispatches as well as the events set up in our parent class. And now what we'll do is we'll just go over to override and add the tree start and the tree stop events to our event graph. Drag these up and then hook them up like so. Then compile and save. And once we compile this in the parent class, you'll find that if we go back to our child evaluator and over here in the override section, if we click override, we now have those events, the on-target perception forgotten and on-target perception updated, that we can simply add to our event graph like so. Add the on-target perception forgotten. And we can now hook these back up. So this is maybe just a little bit of a cleaner way of implementing our code so that there's less clutter in this particular evaluator, but we're not quite done with this yet. And the reason is because there's actually no bindings being set up in this evaluator, and we're not implementing the parent evaluator in our state tree. So that means that this code in the parent evaluator that is running on tree start and tree stop is not actually going to run unless we make use of a special node in the child evaluator. We go back here, right click on event tree start and then select add call to parent function. Now what this does is it adds a call to the parent function that's noted here, tree start. So if we hook that up to tree start, it means that when the tree start event in this evaluator fires, it's going to call the tree start event in the parent evaluator and thus set up the bindings. We can do the same with the tree stop. We right click and select add call to parent function and then hook that up like so. So now if we compile and save and then go and press play, you'll notice that everything is running as normal. Escape out of that, and let's go back to our evaluator. So that's how we can make use of inheritance to keep our code a bit cleaner in our child tasks. But now let's go and have a look at some of the code we implemented in our previous video as well. Now, if we were to just expand this out a little bit, and I'm going to expand the code inside our macro here. So if we right click our macro and click expand node, just so that we can take a look at some of this code for a moment. What's happening here is we've actually created a bit of a duplication of processes. So if we check out of this event on target perception updated, we're checking to see if our stimulus has been successfully sensed. And then if it's not successfully sensed, we're then checking the class of the stimulus to make sure that it's of type site, and then handling our lost site function. But you'll notice that in our handle site stimulus function, if we double click on this, we're doing much of the same as well. We're checking the class of the stimulus to make sure it's a site stimulus, and we're checking if it's successfully sensed. So, but we've already done both of these things. So there's a bit of duplication of processes going on here. So we're going to make this a little bit more efficient. So if we go back to the event graph, we're going to delete this Boolean check here and just hook up this like so. If this event has run at least once, then we have received some kind of sense stimulus. The only time where we need to clear this Boolean check is once we've forgotten our target completely. So this is fine like this, because now what we're going to do is we're going to implement this handle target lost site function inside our handle site stimulus function, which logically makes a bit more sense because we're already handling this code inside of our handle site stimulus function. So we're going to delete all of this and then select our target lost site function, press Control X, and we'll go inside our handle site stimulus and then Control V. And now, if we zoom in here a little bit, if successfully sensed is false, we will handle our target lost site function. And this is just a little bit cleaner of an implementation and getting rid of a duplication of tasks. And something else that I will do over here is that at the moment, we're checking to see if the return value of our received stimulus is of type site. And it's also checking to make sure that our received any sense stimulus Boolean is also true. But because every time this event fires, this Boolean will already be true, then we don't need to check whether or not this is true because we already know that it's going to be true. So if we go back to our site stimulus function, we can delete this Boolean as well as the AND Boolean and just hook up the Boolean like so. And now finally, if we go back to our event graph, we won't be needing the handle initial stimulus macro anymore, so we can go ahead and delete that. And we can simply collapse these three variables into a function. If we go to collapse to function, and we'll call this handle initial stimulus info. So there we go, just a cleaner and more efficient approach to handling our site stimulus. So that's all we need to do for our evaluator for now. We'll go ahead and compile and save that. And we'll just make sure that our parent evaluator is also saved. And we can go ahead and close both of these down. Now let's review the state tree code. So we'll go back to our alien folder, and then we'll open up our state tree alien behavior. Now, the first thing that we'll do for our state tree is I'm just going to add in a new state. So we'll go to new state, and we'll just call this idle. And we'll drag this and just drop it right on top of the root, which should bring it back up to the top. And this is just going to be a state where it will be helpful to debug some site stimulus by making sure the alien is standing idle. And we'll add a motivation type for this. So we'll go to our content drawer, and then our data tables folder, and open up our motivation data table. And we'll add in a new row and simply call this alien.motivation.idle. and save. And for now, we'll also just set the default motivation state as idle so we can see that this works. Go to alien motivation and select idle. And for our idle state, we will add in an enter condition of type compare gameplay tags. Our left tag we will bind to our parameters motivation. Our right tag we will set as alien motivation idle. Exact match can remain unchecked. And our binding description will set to motivation. And we'll just compile and save. And we're simply going to add in a new task of type delay task. And we'll check run forever until we transition. Now, the way that we're going to transition out of our idle state is to check whether our motivation gameplay tag is not alien motivation idle. But this means that we'll need to make a slight change to our state tree condition so that we can check an inverted condition. So we'll go back down to our content drawer, to our alien folder, and then we will go to our conditions folder and open up our compare gameplay tag condition. And actually, just before I make a change to this, I realized after publishing the last video, I realized that I didn't show the class default names that I set. You can just set blueprint category to alien NPC behavior, and blueprint display name, I just set this as compare gameplay tags. So now what we're going to do is we're going to do an invert check. So what an invert check means is we want to get an output return to see whether or not our right tag is not equal to our left tag. And this is pretty simple. All we'll have to do is just select all of this, drag this out a little bit, and then we will drag out from the return node and type in select and then enter. Our index wildcard, we will use a Boolean type. So we'll create a Boolean variable and call this invert. We will expose this to the editor and just drag this onto the index wildcard. Now we'll just compile this so we can check the default state, and we want to make sure that the default state of invert is not true. So if invert is not true, we will just use the regular default value that we have been using. But if invert is true, we want to use a not Boolean. So we'll drag this over here and then drag out from return value and type in not bool and use the not Boolean and then hook this up to true like so. So if invert is true, we will return a true result if our right tag is not equal to our left tag. And we'll also make an update to our get description function as well. I'll highlight this and just drag this out of the way down a bit, and then move these out a little bit and disconnect this wire by holding down the Alt key and clicking the pin. And then out of operator, we're going to drag out and type in select text and then hit enter. And we're going to drag our invert Boolean onto the Boolean input. And if invert is not true, we will use our default value, hook that up to B. And if invert is true, we're going to highlight both of these and duplicate them. And then in front of the text for A, we will type in capitals N-O-T space. And the same for B. At the start, we'll type in not in capital letters space. And then hook that up like so. And then compile. So now if we go back to our state tree, with our idle state selected, we will add a transition rule. And our trigger will be on tick. We will transition back to the root. And we will add a condition of type compare gameplay tags. Our left tag, again, we will bind to our motivation parameter. Our right tag, we will set as alien motivation idle. Our binding description we will set, and this time we will select invert. And you'll see that our description has updated to check whether our tag of type motivation is not a match for alien.motivation.idle. And if that is true, we will exit out of this state and return back up to the root. Let's compile and save that. Now I'm also just going to make a change to our color theme because I don't particularly like the default color. I'm just going to change this to a kind of bluish purple. Okay, great. Now we'll discuss how we're going to change the motivation from idle to not idle in a moment. But now we're just going to talk about how to make some minor performance improvements to our state tree. Because on a few of our states, we're utilizing the tick function, including this idle state here. You can see from this icon here that this state contains at least one task that ticks at runtime. And we're running the tick by checking the value of our motivation parameter each tick. And when that value changes, we will exit out of this state. Now, one of the improvements that came to Unreal Engine version 5.6 is that we can set a custom tick rate for each of our states. We can check our current tick policy over here under the Common tab under Schema. We have the scheduled tick policy. By default, we are allowed to change the scheduled tick policy, but we'll just change this to allowed. And with our idle state selected, we'll go over here and we'll scroll all the way up to the top. And then under the state category, we have this custom tick rate option. If we check that, by default, it is set at the normal tick rate, so this will tick every frame. But depending on the performance of the game, our frame rate could be anywhere between 90 to 120 frames per second. So in other words, our transition rule will be checking to see if our motivation has changed 120 times per second. But what we can do is we can change this to, let's say, 0.2, and then rather than checking every 90 to 120 times per second, it's now only going to check 5 times per second, which will not really have any impact on performance at all. Now, we also set a similar transition rule in our search state. So if we select our search state, you'll notice a similar transition rule down here on tick. So if we scroll up, we'll set a custom tick rate of 0.2. Our move to random location state doesn't implement one of these transitions, but our move to function is checking our point of interest parameter every tick as well. So we can set our custom tick rate in this state also to 0.2. Now let's check some of our other states. I don't believe the attack state is utilizing tick, but our has attack target is checking a transition rule on tick. So we can make a change to this custom tick rate, change it to 0.2. And we'll do the same for search for attack target as well. Set the custom tick rate to 0.2. And one final change I'll make as well is I'll select our wait task down the bottom here for our search for attack target. And in some of my testing, I found that this delay task is sometimes conflicting with the max age setting that we set for our vision stimulus. So what I'm going to do is I'm just going to set this delay task to run forever. And then on transition, I'll change this to on tick, and we will transition back up to the root. We'll set a condition, compare gameplay tags. Our left tag, again, we will bind to our parameter motivation. Our right tag, we will set to alien motivation attack try find target, and we will select exact match, set our description, and then select invert. So when our gameplay tag is not an exact match for attack try find target, we will transition out of wait back up to the root. And of course, we will set a custom tick rate of 0.2 and then compile and save. So now that we've set a custom tick rate for our states, we've lifted some of the burden on our performance. The tick rates that we've set will not have any real significant impact on our performance. If you were very, very particular about not using tick, you could drive these transitions using a state tree event rather than checking conditions on tick. But I found that this approach is perfectly fine. And it's also the approach that Epic Games appear to have used in the state tree examples that come with the first-person template. And before we move on from our state tree, I'm just going to make a change to some of our debug text tasks. I'll start with the idle state, and I will add a task. This will be of type debug text task. And what I'm going to do is I'm going to set the color depending on the color scheme that we've used for our state. So I'll select the color for this. I will copy the hex value and paste the hex value into our text task. And for the text, I will write is idle. And we will bind it to the actor's location. Next, we'll select the move to random location state, and then we'll scroll down to the debug text task, and we will change the color to the hex value of our search color scheme and paste. We'll do the same for the weight task. Under debug text task, we'll change the color. Next, we'll select our move to target state. Add a task of debug text, and we'll copy the hex value for our attack color scheme. Paste that in like so, and we'll call this moving to target. We'll bind it to the location of our actor, select the weight task, add task, debug text. We'll paste in our hex value again. And just call this weighting, bind the location to the actor. Next, we'll select the move to last known location, add task, debug text, paste our hex value again. The text will write moving to last known location. Again, we'll bind this text to the location of our actor. And then finally, our wait state, we'll add a task, debug text, paste our hex value, and just call this waiting. And then finally, we'll just make sure that it's bound to the location of our actor and then compile and save. And now that that's done, I also mentioned that I was going to show how we will change from an idle state back into a normal behavior state. So we'll work on that now. Now, previously what we've done is if we go back to our Tute content folder and then the blueprints, characters, and we'll open up our third person character. Previously, what we've done is when we've added some debug code, we've added it directly to our character. But because we will eventually be transitioning to a first-person character, because Alien Isolation is a first-person game, we want to set up our debug code so that it will work with both characters. So what I'm going to do is I'm actually going to create a player controller class that we can use interchangeably between either the third-person character or the first-person character. So first of all, what we'll do is we'll go to our content drawer and go to our Tute content folder and then blueprints. And then in here, I'm going to right-click and create a new folder, and I'll call this core. And we'll go inside there, and the first thing that we'll do is we'll create a custom game mode. So we'll right-click blueprint class and then select game mode base, and we'll call this GM_alien. And then I'll also right click again and select blueprint class, and this time we'll create a player controller class, and I'll call this BP_alien_player controller, and we'll save both of those. And now let's open up our game mode. Now, with class default selected, we will set the default pawn class, which for now we will keep as our third-person character. So we'll select the drop-down and select BP third-person character. And we will also set a default player controller class. Select the drop-down and we'll select our BP alien player controller. Compile and save. And we'll go back to our level and then drag this out and then select world settings and then filter for game mode. And for game mode override, we will add in our new GM_alien and then save. Now let's open up our player controller. So the player controller class is generally where we would put all of our code that would control our various characters. Now by default, Epic Games seem to put their controls into the character classes themselves. This isn't generally the way that I like to do it. I prefer to have the controls in the controller class. It does generally keep the code where it should be and prevents a lot of code clutter from combining all of our code into just the character class. But for now, we're going to use the player controller class just to store our debug code. So we'll go back to our player controller, and then we'll select the event graph. So first things first, what we're going to do is we're going to add in a debug key to toggle the alien's motivation between its idle motivation and its search motivation. So if we right click and type in debug space key M for motivation. And now what we're going to do is we're going to create an event dispatcher. Think of event dispatchers as Unreal Engine's messaging system, so like a loudspeaker that can broadcast announcements to anyone who wants to listen. So when we want something important to happen, an event dispatcher can broadcast this to other parts of the game, and other parts of the game that care about this event can bind themselves to listen for these broadcasts. We've already been using event dispatchers in a sense when we bound our own custom events to events from our AI perception component. But now we're going to create our own event dispatcher. And to do that, we can go over to our My Blueprint panel and scroll all the way down to the bottom to this section called Event Dispatchers. Now, the player controller already has a number of event dispatchers that come with this class, but we're going to create our own by clicking this plus button, and we'll call this event dispatcher toggle debug alien idle, and then compile. And we'll drag this event dispatcher onto the event graph and select call, and then hook this up to pressed. So when the M key is pressed, it will call our event dispatcher. Now we need to set up a way to listen for this event dispatcher, and we will do that in a state tree task. So we'll go down to our content drawer, go up to the Tute content folder, blueprints, AI, alien, and we will create a child task. So we will right click our base task and create a child blueprint class, and we'll call this st_task underscore alien underscore toggle debug idle. And we will just move this into the st_task folder and select move here. Now let's open this up. Let's set a default category. And for this blueprint category, we'll call this alien debug. And then under blueprint display name, toggle debug idle. Compile and save. We'll go back to our state tree and we will implement this as a global task. So we will select the add button that's next to global tasks, and we'll select toggle debug idle, and then compile and save. Now let's go back to our task and set up our code. And we will select override and enter state. Now what we want to do is we want to create a listener that will bind a custom event to our event dispatcher. Now our event dispatcher is originating from our player controller character. So what we will do here is we will right click and type in get player controller, and we will need to cast this to our specific player controller class. So we will cast to BP underscore alien underscore player controller and hook this up like so. Then out of the return value, we can bind event to toggle debug alien idle. And now we'll create a custom event by dragging off the event delegate, select add event and add custom event. And we'll just call this toggle debug idle and compile. So now whenever we press the M key, it will trigger this custom event, which we can then use to implement code to update our motivation in real time. But just before we implement our code for toggling our motivation, we should check what the current motivation is at the time the game starts. So we will go ahead and create a variable for our motivation parameter and call it motivation param. And this will be of type state tree property reference. We'll expose it to the editor and compile. And then we will set the reference type to gameplay tag. And we'll drag it out onto the event graph and then select get property reference. And this time we want to see if the reference is equal to a particular gameplay tag. So we will drag off this reference pin and type in equals. And we want to check if it is currently equal to alien motivation idle. And then we'll create a branch. And if idle motivation is true, we will set a Boolean variable. So create a new variable and call this is idle ? And change it to type Boolean. And then we will set the value as true off the true pin and set the value as false out of the false pin. So just to recap on this so far, when we enter our state, we will first get a reference to the player controller and cast it to our custom player controller class. We will then bind a custom event to the event dispatcher that we created in our player controller class. And then after we've set up that binding, we will then check the value of the current motivation and set a Boolean variable based on whether or not the current motivation is idle. And now we can set up our toggle debug idle code. So when we press the M key, this custom event will fire, and we want to check whether or not the alien is currently set to idle. So we will drag off our Boolean variable and select get, and then create a branch. And if our alien is currently idle, we want to change it back to his normal behavior on toggle. So we'll get a reference to our motivation param, and then get property reference, and then set by ref, hookup reference to target, and then we will set our motivation to alien motivation search. And then we'll hook up this like so. And then finally, we want to update our Boolean variable to false. But if is idle is not true, we want to change our alien's motivation to idle on toggle. So we will copy all of this and paste, hook this up to the false branch. We will change our alien's motivation to alien motivation idle, and then set the Boolean variable to true. Compile and save. And now just before we implement this, we need to go back to our state tree, and we need to bind our motivation param reference to our motivation parameter. So we will bind this to parameters, motivation, compile, and save. And now with our motivation set to a default value of alien motivation idle, the character should start in an idle state, and we should be able to toggle his motivation. So let's go play. So we started in idle, and if we press the M key, we've now updated his motivation to search. Press the M key again. You'll notice that there is a little bit of a delay because it's just finishing off tasks from its search state. But we can make this transition back to idle a bit snappier by adding in a state tree event. So if we go back to our debug idle task, when we set our motivation to idle, we will also send a state tree event. Then we will right click the event pin, split struct pin, and then set our tag to alien motivation idle. Now, if the alien also starts in an idle state, we also want to send this same event on the enter state as well. So we'll select this and copy, and then up here, paste, and then hook this up to is idle as well. Now to implement this event in our state tree, we'll go back to our state tree and we will set our transition rule from the root. And because the root state is always active, the transition rule will always apply when this state tree event fires. The root selected, we'll add a transition rule and then select on event. And then under required event, we will set the tag to alien motivation idle. And then we will transition to the idle state. Compile and save. Now when we press play, if we press the M key to change state, if we press the M key again, it will snap straight into an idle state. And now just before we finish off today's lesson, we'll add in some final debug code so that we can speed up or slow down time as needed. This will just help us to debug certain things in upcoming videos. And we'll also add in a button to pause and unpause the game as well. So we'll handle the pause game first. So back in our custom player controller, we will right click and type in debug key enter. And then when we press the enter key, we will add in a flip flop node. Then we'll right click and type in set game paused. And the set game paused function will pause the game if this boolean is marked true, and it will unpause it if it is marked false. What we will do is we'll hook up the A and the B into set game paused, and then we'll hook up the boolean value into the boolean input. So what this means is that when we press the enter key, it will flip between the A execution and the B execution. But even though both of these are entered into the same node, it's going to update the value of our boolean each time we press it. So the first time we press the enter key, the boolean value will be true. And then the next time we press it, the boolean will be false. But one thing that we need to make sure of before we implement this is that we need to select the debug key enter, and then in the details panel up here, there's an option that says execute when paused. We need to make sure that this is marked true. Otherwise, when we pause the game, we won't be able to unpause it. Compile and save. And now if we can test this, press the M key to get the character moving and press the enter key, which now has paused the game. And if we press the enter key again, it has now unpaused the game. Great. Go back to our player controller. And now let's add in a way to speed up or slow down time. To do this, we will use the left bracket key to slow down time in increments, and we'll use the right bracket key to speed up time in increments. So we'll right click and type in debug key left bracket, and then we'll right click and search for a function called set global time dilation. Now this has a float input called time dilation. If the time dilation value is set to a value of 1, this means that time will move at the normal rate. If we were to change this to value of 1.5, it means it will speed up 1.5 times faster. Conversely, if we change this to 0.5, it means that time will slow down to half the speed. And a value of 0 means that time has stopped completely. We will set this to a default value of 1. What we will do is we will create a float variable to handle our time dilation. So if we go over to variables, we will add a variable and call this time dilation. The variable type will be float. Compile. Now this is also very important as well. We want to make sure that the value of our float never goes below 0. So under the details panel, we'll go to a value range, and for a minimum value range, we'll type 0. And for a maximum value range, we'll say a value of 4. So the maximum value we can speed up time will be 4 times faster than normal. And we will also just set a default value of 1. Compile. So when we press the left bracket key, we will slow down time by an increment of 0.25. So we'll drag off the time dilation variable and select get. Then we will subtract. So we'll press the minus key to subtract. And we will subtract the value of 0.25. And we want to make sure that the value never goes below 0 or above 4. So we will drag off this output pin and type in clamp. And we want to select clamp float. And make sure that the minimum value is set to 0 and the maximum value set to 4. And then once we have that output value, we will set the time dilation variable and hook that up to pressed. And then we can then hook that up to the set global time dilation and add in our value. And it's also going to be helpful just to print some information to the screen. So we'll drag off and add a print string node. I'm going to set the color of this to a bright yellow. And then out of the in string, I will drag off and type in append. The append node makes it possible to combine more than one string into a single string. In the A input, I will type in global time dilation, and then colon and space. For our B input, we will drop in a reference to our time dilation variable, which will automatically add a convert node from float to text, from float to string. And then we'll also just add a pin. And for our C input, we will type space, and then in brackets, we will type minus 0.25, just to show the increment that has been set. Then we will compile. You can go ahead and test this now. Go to the game, press play, press the M key to change our character's motivation, and then we can press the left bracket key. Now slow down time to 3/4, again to half, and now a third. And if we move, you'll see that time has slowed down to 0.25. And if we press it again, time has slowed down to 0. To escape out of that, we'll go back to our player controller, and now we'll add in some code to speed up time by an increment of 0.25. So now we'll right click and type in debug key right bracket. This time we will just copy all of this and paste, hook up to pressed, and this time rather than subtracting a value of 0.25, we will add a value of 0.25, which will be clamped to a minimum of 0 and a maximum of 4. And then over here, we also just want to make a change here. So rather than the minus symbol, we'll just add a plus symbol. And we might just change the color to maybe a bright orange. And then compile and save. So let's go ahead and test this. Press the M key. And if we press the right bracket key, you'll see that time is now speeding up. And it will speed up to a maximum value of 4. And if we slow time down, you'll see that it will slow down to a minimum value of 0. Great. And let's just comment all of our debug code here. So we'll go back up to the top here and press the C button. So toggle debug alien idle. Highlight the next row, comment toggle pause game. Highlight the next one, slow down time by 0.25. And then finally, speed up time by 0.25. So this debug code will just help us in the future videos. It will make it easier for us to diagnose certain issues, but I also hope that you learn something new from this lesson as well. In the next video, which is available to watch now, we will finally implement the prediction sense. So I will see you in the next lesson. The project files for these lessons are available to download from Gumroad completely for free, but if you would like to support the work that I do, please consider making a donation via the Buy Me a Coffee link in the video description, or by adding a monetary amount in the Gumroad link if you choose to download the project files. And a very special thank you to the people who have already supported this channel. Your support means a lot.